Alright, continuing on with the component placement of my motor controller board. I have finally placed angle. There's still a lot of work to do, but most of this rat's nest has been untangled now. So it's mainly now to place the components in more detail and make sure that no designators overlap or no components overlap each other either. So it's basically a more kind of like fine-tuning of this component placement now. So the first thing I'm going to do here is I'm going to align all of these connectors here, and then I will go in here and maybe I would have to rewire some things. I don't know yet. It all depends on how I can place all of the components here in the middle, because I think that I'm going to want to have the preferably, because I also, and that means that placing them side by side, like sort of like this, would mean that I will have to place them farther apart so that the annotations will fit. So it's better to have them possibly here somewhere, and I think they should all fit into a row here, but we'll see. Let's start with the connectors at the top here. I'm going to align all of them so that they are all aligned together. And I can do this by, I'm going to move this one first a little bit, maybe like that, just so that I can then do the distribution properly. Let's see. I think we can do like this. Align, distribute, align, I'm going to align to top. This should align all of them to the edge there. And then I'm going to distribute. So distribute horizontally. Let's see. And I think this should work fine. Right. So the way that alignment seems to work is that it takes the kind of like the boundary box of the connector. So if I have, for example, courtyard sticking out a little bit more, then this ends up being slightly misaligned. So let's see what the position of this is. This one is at, yeah, it has a very weird position. So what I could do here is just, they're supposed to be the same size in terms of the length. So from this, like from here to here, it's supposed to be 9.2 millimeters. So they're all supposed to be 9.2 millimeters because they're horizontal connectors. So let's open this one with footprint editor and double check this. So we have that the courtyard is, let's see here. So this is supposed to be 9.2. This was 9.25, so that's not correct. Let's make this 9.2 there. And I also need to kind of move this so that it's 1.2 above the 0 line. Let's see, 1.2 there. Okay. And actually, let's also check this. So we have there to there is going to be 245. Yes, it's supposed to be a little bit bigger as well. And this one is, let's make this 1. And this is important for the placement, because if we don't get a situation where connectors actually don't even fit if they're too close. Let's see. I'm gonna make this courtyard. Okay. And this graphic line can then be moved here so that we also get the courtyard, which would be aligned with the graphic with the silk screen. So let's put the fab layer. It's up there, and it needs to be slightly adjusted here as well. And then we have this, let's see, so this will be placed at 24.5. What we need to do here is move this one to 24.5. Press space and then go 2.45 to the side and 1.2 up. So it's going to be there. Okay, perfect. This one also is going to be 12 in thickness, like that. And I'm going to slightly move out the courtyard. So this is going to be very important for alignment, that all of these measurements are correct. Besides the graphic, so I don't really care about it that much. Although I still think we need to make it, we cannot have the fab layer, or any layer for that matter, sticking out, because then KiCad will align things to the part that sticks out. Let's see. Let's hide the silk screen. No? Here. No, actually, wait. What did I just do? I need to bring up the window again. Where's the window? Come on. Can I get the window? There. So I need to hide the silk screen, and then I can adjust the courtyard. There we go. Okay. This should be fine. And I update the footprint. And we now should be able to align these two precisely. Yeah. Now they're precisely aligned. Now these two also need to have the same size. They are, as far as I can see, they're not precisely the same size, because we have the courtyard sticking out. So I'm just gonna fix, this is a minor change. I kind of previously thought that this was not that important, but I realized it is. So let's make sure that it's all aligned. It would be nice if KiCad to the center of component. Same thickness. Oh, 12, of course. There we go. And courtyard, so that it's slightly silk screen. And then I should be able to get all the connectors aligned to the edge. Let's see, front silk screen. And I can do like this. And I'm gonna also, while I'm at it, I can fix the fab layer. There we go. silk screen, and seems to be fine. I'm just gonna check this positioning of this. Let's see, it's 705, so that means that this one is supposed to be off a little bit. Yeah, all of them. Yeah, so now it's positioned at 0. And this one would be 7, yes, that's right. Would be 9:45. This one is supposed to be starting at X point 9:45. 9:45. Just let's see, like that. Yeah. Now I'm being a bit perfectionist about this. It doesn't have to be this exact, but might as well do it, because while I have this footprint open, I might as well just fix any issues I can see with it. Let's see. That's it. Let's do the fab layer. So that they look good when they're side by side. To get it perfect, I would need to write a script that will generate those footprints precisely. And I think there is a script somewhere, but it's not very, the current script that they have, I think it's KiCad library utils that they use to generate the footprints. It's not really, I would need to modify it to make it generate the footprint precisely as I want it. So it's easier to just, let's move this one there. Okay, save and exit, and update. So a tiny little bit, but now it looks good. So then this one will just fit precisely at the edge of the PCB. I'm going to place them from the edge itself, so that I don't want anything to overlap this line that defines the edge of the PCB. And then I could, let's see here. Yeah, let's do it like that. I should probably also align the edge itself so that it's aligned at the 0 point. Let's see, where is the 0 point? Is the 0 point there? No? Okay, so the 0 point is there. Precisely there. Okay. I wonder if KiCad allows changing the origin. Nope. Let's see. Come on. A little more, come on, a little more. No, don't go back. My mouse wheel is kind of broken. I need to get a new mouse. I'm gonna place this right there, precisely there. Perfect. Yeah. $46.24. Okay, good. Then I'm gonna do the same thing with these connectors. And then I will need to also move any components that are directly connected to the connectors properly. So yeah, what I can do actually is I'm going to do it like this. I'm going to align these two. So let's see what position this needs to be at in order to be aligned. And I can just press space, and I can also I get this guide precisely at the, let's see, yeah, it's actually precisely at the alignment point. So place it there, and then I'll align the last one precisely the same way on either side. So I can move this one here and just align it manually, then press space and move this one here. Yeah. And so the important thing is just along the x-axis here, so that we get proper distribution. It looks exactly the same way. And distribute horizontally. So what it does, let's see, this was wrong. This was weird. Why did I get that? I was just about to say, like, what KiCad does is you place the side components that you distribute, and it's supposed to place everything else. But it seems that this didn't actually work. Maybe maybe it was because some of them overlapped. Let's see. Let's just do some manual placement here. Make sure that nothing overlaps. And I'm pretty sure it's gonna produce the same wrong result this time as well. I have to see what KiCad will actually do when they're placed like this. So these two are overlapping, and then we have this one, which is quite likely to actually overlap. Did I do this right though? Let's see. And make sure that the dx is 0. Okay. Space there, really. What if I and just distribute these? And I can press Ctrl Z just. If this is going to work. So align, distribute horizontally. Yeah, this worked. So it seems to be that it needs to be kind of aligned, overlapping. Maybe, what if I do like this? Because now that second one is not overlapping anything, so maybe that will not confuse KiCad. Align, distribute horizontally. Right, could it be something about... That is very weird. So there is... So I'm not sure why it does that. There is some problem with KiCad or something. So I'm just gonna basically place those footprints manually. Courtyard is not extending outside there too much. And I'm just gonna check whether this line is precisely 9.2. No, it isn't. Okay, alright. So it's supposed to be 8. This one's 9.2. And courtyard, move it out a little bit inwards towards the silk screen, and just gonna fix these ones. Yep. This only needs to be done once. Whenever I reuse the footprint, I can just use the same footprint everywhere. So is this one. Really? Did I just forget to update this part? Okay. And the joystick connector also needs to be updated so that we don't have the courtyard sticking out too much. Fix any issues we see with this connector as well. That is 8. Yeah, perfect. So these gray lines are on two different layers. One is fab and one is courtyard. That's why I'm adjusting both of them. Update footprint. Let's see. Next is this one. Just place it there. Can I see the position of this somewhere? Let's make this 60. Okay, right. That's because this one is rotated. So can't really do that. This is one of these things in KiCad that isn't really well developed. Having better alignment tools would be definitely useful. Let's look at this in 3D. So this is what the board looks like in 3D right now. It's nice that all of the connectors are aligned, but there's still a lot. As I said, I want to move these connectors and I want to place them actually rotated in one row preferably. But that could also interfere with, since this is through-hole connectors, anything that's through-hole it's good to remember that any through-hole part is taking up all of the layers where the holes are. So placing these connectors in a line means that we have to reserve some space between the connectors so that we can route the wires that go here, for example, to the CAN bus and to the EtherCAT. But I think in general it's starting to come together. I can align these parts as well. I'm going to align them to the edge. So the board is now 13 centimeter wide and 21.5 centimeter long. And this is the USB connector. And we place it right at the PCB edge. So we need to show the fab layer so we can place the PCB edge precisely there. And I can turn off the fab layer. This is the indicator diode. It will just be here at the edge of the PCB. and this CAN port, D port. This can go there. That's fine. The idea is to have a switch that allows picking the CAN address using hardware, so that it doesn't need to be programmed, which makes it easy to replace these boards. If one needs replacement, you just set the same CAN address. It's going to be 4 lower bits of the CAN address. Chip, I think this is maybe if I actually move with this chip, and let's see, I need to, I think, if I rotate this, I end up with this. Okay. Okay, that was just like a test point, but that was just and this would be, we actually need to annotate this. So this is a new footprint for the debug interface, basically connected here. So we need to annotate this. This will be, let's see, we have VCC. Let's place some text here. GND and okay, that's actually TX. So we have GND here. This is the debugging interface. So I have a UART and I have a software debugger. So serial JTAG. Yeah. RX going to be pin number 4. Pin number 5 is nReset. SVD IO. Let's make this just IO. Boot is 9. And 10 would be not connected. Actually, it would be better to align this one to the left. And let's see, distribute vertically, and then this one to the right. Yeah. All right. So the debug connector connects to a few pins there and a few pins on adjacent sides. So maybe I think it would be good to place it there. I'm going to delete the lines for now. Even though it's so pretty to have those lines, I think that right now they're just getting in the way. And let's see, this would be test points for this chip. Be connected mostly to, so actually then let's see, yeah, I think this seems a little better. Let's place the UX here. Right, let's get this out of the way. Yeah, this is not really out of the way yet. Maybe if we place the UX there and then this one here, and then this one, that one, be perfect. These two op amps, I guess. Yeah, there's a bit of space there. Some of the designators as well, so they don't take so much space. Can do that a bit later. So maybe something like that. This designator, which can be, let's see, there. And test points can obviously be moved out a little bit. Or even perhaps rotated like this. A bit to like group at the same time, at the same place on the PCB as well. Let's see. How does this look? How does this look? That's a bit better. By the way, let's see. It's lagging a bit, but right. So it would be nice to have the connectors rotated the right way. Come on. So that all of them are rotated actually this way. Because that would be, or actually, yeah, it doesn't really matter. But at least so that they're connected, so they're rotated in the same direction. This is an SPI parallel interface, which will be used for the LCD interface. And this can basically be just close to the LCD connector. I'll just move, actually I'll modify this connector, and I'll change the M data to be something shorter because I think that just make it MD, and the LED minus can be L minus. Actually LK for cathode. Let's make it L minus. Okay, and this would be RD and GD. That's better. We can even move them a bit more. So we could, I can move all of these. Let's align them first. Align, distribute, align left. And then just move them a little bit closer. And the same. Awesome. And this designator can then be placed there, and I can then move this chip closer to save some space. Yep. It's very close because if it's good if it's a little bit farther away from the connector. Otherwise I'll melt the connector with the hot air. Let's see. These ones, yeah. Now that I have a bit more space there, I can actually move these connectors slightly out, like this. Perfect. I think that is a bit off grid, so let's update this side as well. And I'm placing all the fab, this is the fab layer, yeah, this is on the fab layer, all the fab texts underneath the connectors, so that they're enclosed by the fab rectangle. Let's see. And what else can we here that we need to rearrange? So one way to get a better feel for what things are overlapping is to hide the rat's nest. You can hide the rat's nest like that, then we just see the components. Hide other things. Cluttered view of the. So I'm just going to continue lay things out a bit better, try to rearrange things so that everything is so that everything fits, so that I have enough space to route out the connections, and I'll continue in the next video.